Welcome to my talk on application security in Delphi, and hopefully by the end of it, you'll be able to code securely in Delphi, at least a little bit more so. So a little bit about me. My name is Alister Christie. I'm an Embarcadero MVP, and I run the LearnDelphi.tv website. I've published a couple of books. So Code Faster in Delphi was my first book, and then later Code Better in Delphi. And lots of other stuff. I have a YouTube channel with 250 videos or something like that on Delphi topics. Plus I've got some commercial content. You can go to LearnDelphi.tv to find out about that. Our agenda, we've got a bunch of topics related to how to code securely in Delphi. And we're going to start off with some information about how broken Win32 is with related to GUI applications and how they're not particularly secure. So let's start with that. Now, I have this small application. Maybe this is something you've written, for instance, and you log into it, and depending on the user you log in with, various controls are hidden or disabled. So typical Delphi application. So this is basically a Win32 application. And I have this other application. And if I run it, and I want both on screen at once, so I'm going to take this one over here. And what I'm going to do is type in form 39, which is the caption on the form, and go get handle. So that's the Windows handle for the form. And then enumerate windows. It's going to go and enumerate everything on the form that has a Windows handle, which is all these controls. So we have a radio group and the various group buttons. We have our delete all customers, delete customer, add customer, and overload core and self-destruct. Now, you may have noticed these buttons down here. So if I go to delete all customers, which is currently disabled, I can go enable window, and now it's visible, and I'm logged in as a user, and yet I can now delete all customers. And better than that, I can go to the overload core button, show the window, and then enable it. And then I can overload the core and self-destruct, which is probably a bad thing. And what hacker is not going to want to click on that button? Anyway, so you will have noticed there is no elevation of privileges or anything like that going on. All I'm doing is from this application, I'm sending Windows messages to this one. So if we have a look at the source code, I'll close them both. And go to the form. So get handle, it's just passing in the window name, and I have this function which just enumerates through all the windows and tries to find one with the caption that we've specified. And that then fills in the handle, and then I can enumerate windows, which just we enumerate. So there's get to the Windows handle, and then we enumerate over all the controls on the form, and we pass in this procedure, which then just creates tree view items with the handle, class name, and caption. If you look at the various things that are passing in. So it's pretty simple. And then we just say enable window, and we're calling the standard Windows enable window, and we're passing in the handle that we obtained, which is, I have a special tree view node, which has the various properties. But basically, we're just sending a Win32 message from our window enabler application to this enabler test. And I did do one little cheat. So if I run this, and this one, and I type in the enumerate windows, you will see that we don't get the overload core button. What I have to do is go to superadmin, and then well, if I enumerate it now, it's been made visible, and I'm presuming that Delphi doesn't allocate a Windows handle when a control is not visible. Well, it's only allocated when it is made visible. So if you have on your form a control visible set to true, and then in the constructor of the form set it to false. A handle is probably going to be allocated to that, and you're going to run into this issue here where we can enable controls. So nothing special about this. This is how the Win32 API works, and there's not much you can do about this. So recommendations. So as I mentioned, there's no admin user required or anything like that. A standard user application can do this, and you can download many applications that do this from the internet that can send API messages, Win32 messages to various controls. So long as you have the handle, you can control that control, do whatever you want to it. So basically, don't put code directly behind a control. So if you double click on a button in Delphi, don't put the code in there. It's much better to put that into an action. That gives you a little bit more security. And also, with every action or every time you click on a control, make sure that you are confirming that the user has permission to to do that action. Otherwise, well, we've seen what can potentially happen. So confirm at the beginning of the event. And also make sure your controls are not visible by default. So make them visible when required. That gives a little bit extra security, but not much. In this demo, we're going to build a DataSnap client and server application. Now it's using the old TCP/IP DataSnap technology, which is somewhat replaced now by REST, but there are still a lot of advantages using the TCP/IP connections. So this is an example of some of the security hurdles I've had to overcome in building applications for it. So don't think about the issues with the technology, this particular technology itself, but how the techniques can be applied to other platforms and technologies that you might be using. So enjoy. Next up, I'm going to start with creating a new other DataSnap server. And Windows is good, Forms is good, VCL is fine. We're just going to use standard TCP/IP with the sample methods, and we want the encryption and compression and authorization. Just make sure nothing's running currently on that port, and I'm going to just send from TDAO module. I don't think it's going to matter at all for this. And just going to save everything off. But I'm going to call it server. Okay, and then I can run that and create a new VCL application. And I'm going to call this client. Onto our client form, I want to add a SQL connection. I'm just going to leave it named SQL connection, and I'm going to shove it there somewhere. I need to specify the driver as being DataSnap, and that will hopefully have propagated a whole bunch of default parameters, which are what we want. But I want to turn login prompt off and click connect, and we can connect to our server, which is currently running. Now, what we want to do is call the reverse method. So in our server methods, we have this reverse string. And to be able to call that, I'm going to right click on this and say generate the DataSnap. So it's basically generated a proxy. And I'm just going to save that as unit 2. And what I want to do is add a button, call it reverse. I'm going to chuck it up there. And in here, oh, we need to use unit 2. Dot create. We need a DPX connection, which is on our SQL connection. And we want to free it. And in here, reverse string of our edit. And what I'll do is I'll start by in our SQL connection dot open. And so, in theory, hopefully, if I've done anything right, with our client running, we can now click reverse. And you'll notice there's a slight lag the first time I clicked on it, but it's pretty minor as we were connecting to the server. Now, we don't want to have just any old user be able to access our application. So what I'm going to do is I'm going to shut down the server and go to our server container. And in the authentication manager, there's a couple of events on authenticate. This is one we want. So we need to validate username and password, and there are a couple of parameters. It's user and password. And so instead of valid being true, I'm just going to say same text and same string. Not secure one. So that's our authentication. Very simple. This is not what you'd necessarily use in a real world. You probably look up in a database and all that kind of stuff. But for the purposes of this, that's all we need. Now, if I run that again, oops, run our server again. And our client, that form, and I might save these. So in our connection, if I try to connect now, it's not going to work. And so if we go into our parameters, we need to add a couple of new parameters. The first one is DS authentication user, as of course Alister, and DS authentication password, which is not secure one. We'll leave the one off for now, just to verify that. Okay, that's cool. And one, and it's working. So we should now be able to run the client, and our reverse is indeed working again. Except we've got username and password based authentication. So this is effectively our client and server built. Now the server is going to reside on some server somewhere, nice and secure, but the client application is going to run on a client PC, and a given user can then look at that executable and have a look at what's inside it, which is what we're going to do next. So what I'm going to do is, let's go show in Explorer and type cmd, and here we have our client.exe, and I could open that in Notepad and look at all the strings in it, and that's actually quite painful because there's a lot of information in there, and it's in Unicode, so it's in every second byte that I want to be able to see, and so on. So there is an application in the Microsoft sysinternals suite, which I have downloaded sysinternal suite, there is an application called strings. Now I'm just going to do a quick going to add that directory to my path, and I can type strings, and there's some parameters we can look at that. So what I'm going to do, I'm going to say dot n is 8, so I'm only going to get strings that are 8 or more characters in length, and into client from client.exe, and check it into client.txt. And so we should now have client.txt, which is too big to look at. And if I go show more options, I can edit it in Notepad++. And let's bring that over. And here it is. We can tell it's a Win32 application. And these are all the strings that are contained in that executable, whether they're ANSI strings or Unicode. So what I want to do is have a look at that, and we have our password equals not secure one. So just by searching for that, I have determined our username and password from within the executable. So that's not very helpful. So what we want to do is, rather than rely on this information being stored in the executable, I mean, we could encrypt it within the exe, but what I'm going to do is prompt the user. So let's do that. So to get our password from the user, in the SQL connection, in the before connect, we are going to assign the username and password to the connection properties. And so if we come in here and look at the params, and I can go into code editor, and let's just pull those out. And then in here, let's go like that. And I'm going to need a var. Some values, which is going to be a length of 2, because we have 2 things we want to collect from the user, a username and password. So, whoops, save changes, yes. I can close that now. So I'm going to use input query and say login, and we need to collect a username, and let's get rid of that. And we need to pass in our values. Now, what I do need to do is set the length of values to 2, because we're collecting 2. So if we've failed, we'll just abort. And so what I want to do now is fill in those parameters on the SQL connection. Params, values, oops. So values 0 and 1, and I think that might do it. Okay, so I'm just going to double check that that was cleared from our parameters. It was indeed. And so let's run that. Reverse, so before connect. not secure one, and that worked. And of course, we're now logged in. So we can go back to our command prompt, that one, and rerun the export of strings. And in Notepad, if I Control R, refresh that, we've not got our password, and I search for that. It's no longer in our executable. So our password is safely not present, and someone examining the executable can't determine the password just by looking at the contents of the exe. So recommendations. Basically, don't store anything in your exe that a hacker could use. Usernames and passwords is what we looked at, but database connection strings, that's another obvious one. Encryption keys, certificates, all of those you don't want to provide in the executable in plain text in particular. It helps, if they have to be in the exe, it's a good idea to encrypt them in some fashion. So encrypt strings for data you need to store, and then double check by running the strings utility in sysinternals, and have a look through and make sure there's nothing in that list of strings that you don't want to be made public. So we've fixed the problem with strings in our exe, but what about what's stored in memory? So we're going to do some dumpster diving. So let's come to, and first so our server's running. Let's run the client as well. Okay, so that's running. If I open up Task Manager, just as a regular user, I can right-click on Client and create memory dump file. And this file contains everything in memory. So it is 100 megabytes related to that executable. It includes DLLs and all sorts of things. And then we can run that through our strings utility. But we're actually going to use a different utility. We're going to use procdump, which is another sysutils tool. And I have this little batch file, which starts by deleting all dump files, deleting client.txt, and then we're using procdump to output everything from client.ext, and that creates a .dmp file, and then we rename it to client.dump, or rename all of them to client.dump. There'll only be one at this stage, and then we run strings on it and output to client.txt. So if I save as and throw this in here and go back to our command prompt, we have our do procdump, and it's done. And if we go back to our client.txt and make sure that's reloaded, we see we've got a completely new set of strings. And if I search for our password, in fact, we can go find all in current document, and we can see we've got 4 instances by the look of it. Somewhere, there we go, not secure one, and there it is there in those 2 locations. So we've just kind of pushed the problem further down the road. So now we've got to worry about what a malicious person can do with dumping the contents of our application, or the memory that our application is using. So rather naively, let's start by closing our client, and I'm going to go in the after connect, and I am going to take those 2 values. Let's copy that there. And if I just assign blank strings, and there is actually another location I need to worry about, which is in the dbx connection properties .var. So it's actually the same kind of thing. So why don't I just take that like that? And set those. So this actually doesn't work. I'll just prove that because of the way strings are handled in Delphi, and the memory is not reused immediately. So the actual strings remain. So let's run that and we'll log in. Okay, and then we can do our dump again. And if I clear that, we'll see that we haven't actually removed the password. So what we really need to do is overwrite the string and clear it. We could do that very carefully, or we could use a sledgehammer, which is what I'm going to do. So if I close our client, and what I'm going to do is I'm going to use FastMM. So let's just bring up so use FastMM4. So basically we can download this repository, and I'm very roughly going to, in the search path, add that, and to our project I'm going to add FastMM4, and we can open that. And what we want to have a look for, so there's an include file. If we get through all of this, the FastMM options, and I forget what it's called, something always clear memory or something like that. Always clear freed memory. So what I'm going to do is I'm going to copy that, and where our conditional defines are, and I should probably do this not in debug, but in the sort of root, but I can do it here. In fact, now let's go all configurations. And so when we come back to debug Win32, we've got always clear freed memory defined. I could, if you want to do it in every project that you use FastMM in, you could remove that, but maybe you don't want to do it in the server. It's for performance reasons. It says there's a big performance hit, but it's not really a big deal, I don't think. So now if we run our client, and we do our proc dump, and back to Notepads, go Control R to refresh that, and find all in current document, we are down to 1. And if we look at this, this is JSON, and it's kind of missing a little bit here. We can go to that line. There it is. So here we have this chunk of JSON, which we want to clear. Now, getting rid of this is a lot more challenging, but we can do it. So what we're going to do is we are going to modify the runtime library. So let's close that again. And let's save everything. So I need to go back to my cheat sheet, and we want to open this file. So this is part of DB Express, and I'm just going to save as, and if we come back to our folder, I'm going to save it in there, and I'm also going to add it to the project because we want to modify a line or a couple of lines in this. So let's find this procedure. And what we're going to do is, as well as flushing the buffer, we're going to make sure the buffer is all zeros. And so now that we've done this, this should, and this took quite a while to find, that to get rid of this last occurrence of the password. This was a bit of a challenge. But we can now run the application. Log in, it reversed, run proc dump. Have a look at the client.txt, refresh that. And now if I, well, we'll clear all this and control find, not secure one, and there is none. So we've eliminated our last instance of our password from memory. Oops. And save all. So recommendations. Making sure your memory doesn't contain anything sensitive is far more challenging than the exe itself, because obviously there might be third-party libraries. If you've typed something into an edit box or something like that, then you want to make sure that that text doesn't hang around. So don't leave anything in memory that's sensitive. So if you've got a string, you want to set it, assign a blank string, or if you want to be, you could write all zeros to that string and then free it. But much easier to use FastMM with this always clear free memory. That helps a lot, and it'll help with other things you don't have access to as well. And as always, you want to test, make sure that everything you're doing is successful. So making sure that those strings don't hang around in memory. So we now want to stop our client and server, and we'll go back to our server project. And in the server container, in the transport, there are a number of filters. And we've got 3. The third one is zip compression. This is the last one that occurs. And it's not really, it obfuscates data, but doesn't really help too much in terms of encryption. The ones we're interested in are the PC1 key and the RSA algorithm. So for some reason, by default, this sets a fixed key. Now, if I go into our dump file and search for that, there it is in our client. And potentially a malicious actor could then use that to decrypt the data going backwards and forwards between our application and the server, which we don't want. So the first thing we can do is we want to delete the value, and this effectively means a new key is generated every time the application starts. And for the RSA key, there are a couple of properties we need to set. One is this key length. Now, by default, it's 1024, and that is probably large enough in most instances, unless you're particularly interested in security. I'm going to triple it to 3072. Now, the key exponent, 3 used to be a good number, but it's not many people are using it these days. 17 is better, but 65,537, which is 2 to the 16 plus 1. This is I think it's the largest known Fermat prime. So this number is prime. It's 2 to the 2 to the 4, I think. And it's used because the binary expansion of this is a 1 followed by lots of zeros and a 1, which means it's somehow efficient in terms of encryption. And this needs to be co-prime with something or other. So choosing a prime is a good idea. A lot of technical stuff I don't quite understand, but this large number makes things a lot more secure. And so that's pretty much all we need to do at this stage, and we can run our server and come back, and run our client. Reverse. Not secure 1. And you may have noticed that took a little bit longer to reverse. So increasing the RSA length, so we're with 3072 bits, that's a decimal number of about 1,000 numbers. And so it's made up of 2 primes that are about 500 digits each multiplied together. So there's a lot more computation involved. The last thing we want to do is for this PC1 key, currently it's generating a new key every time the application starts. We want to generate a new key every time a new client connects. Now, to do that, we need 2 files. And if it's not that one, this one. So these 2 files, which I'm going to copy and put in here, and just drag and drop both of these. And I need to add both of these to the server. So, which we are actually we're on the client at the moment. So we just need the PC1 dynamic key added to that. And to the server, we need both the dynamic key and filter utils. And if we have a look in the constructor for this, we see we're getting a new random key, which is generating us a new random key every time for every new connection. Now, to use this, I'm going to go back to my cheat sheet. And we want to add this to our constructor. In here, so use unit, I need filter utils and PC1 dynamic key. And in our constructor, we're going to clear our filters, and then we're going to use, so there's the parameters we used before, and we are not using a default key, and we're using this new filter, which is the PC1, same as the PC1 key, but it's generating us a new key every time. Now, to get these files, that's a bit more challenging because these were, I think, exams in the sample code for Delphi exe8 in the DataSnap folder. So, but they're not there anymore because I guess DataSnap is being a little bit deprecated in terms of the TCP/IP version of it, in favor of the REST. But I still work with quite a few applications that use this. So that's our server done, and let's minimize that. And so we should be able to restart our server. And on our client, all we need to do, and in here, I can just add somewhere. In fact, I don't even need to add it because it's in our project file here, and down the bottom we have in the initialization, it registers our PC1 dynamic key version of the cipher. So if I come back here, what I can't do anymore is just click connect, because the PC1 dynamic key filter is not found. So it's to get that installed, I'd need to create a new package and add this unit to the package and then install that package into the IDE, and then it would work. But at runtime, it's all fine. So that's probably, without going into a lot of effort, about as secure as you can make a DataSnap application, or the style of DataSnap. So what have we done? So there are two algorithms involved in communicating between the client and server. The RSA algorithm, which basically communicates the PC1 key from the server to the client. And so we made that more secure by increasing the key length. And bigger primes means more computation, so it's much harder to factor that large number into its two constituent primes. And as I said, those are each of those prime numbers will be 500 decimal digits approximately, so they're huge. And we also increased the public exponent to the fifth Fermat number. And these numbers are desirable because they're a 1 followed by lots of zeros and then a 1. And that means that somehow the computation is easier with fewer ones in the key exponent. And of course, this number is prime as well, which also helps make it more secure. So for PC1, we removed the default key, which that should be the default behavior, but oh well. So we get a new key each time the server restarts. But we also added code with the PC1 dynamic key that every time there's a new session, a client gets a different PC1 key. So that increases the security between so if one connection is compromised, it doesn't compromise all of them. And for the really paranoid, you'd probably want to replace RSA with something quantum secure, things based on prime numbers. There is an algorithm for quantum computers that allow you to factor primes. At the moment, the quantum computers don't have enough qubits to be able to factor large primes, but that's going to come eventually, presumably. It's not guaranteed. There might be reasons why you can't do large quantum computers, but I'm going to assume that in the future, RSA is no longer secure. And PC1 is now getting quite old, so you might want to replace that with something more modern as well. But it's a very fast and efficient stream cipher. So once we generate our PC1 key and communicate it to the client, then all the communication between the client and server is using that PC1 key, the PC1 algorithm. And so you might in the future want to upgrade to REST instead, and then you can rely more heavily on the operating system for your encryption. This RSA and PC1, I think certainly the RSA and I think the PC1 are implemented in the open SSL DLL. So that's another reason not to use it. By the description of this slide, Little Bobby Tables, I hope you're already familiar with this XKCD cartoon, where some parent has named their son Robert apostrophe close bracket semicolon drop table students semicolon dash dash. So this is the basically SQL injection. So we'll be covering this in the next few minutes, or at least very basically. So let's have a look at the demo. So I have this application called Northwind. And what happens is there is a connection Northwind, and if we have a look at the database connection, you'll see it's SQLite, and it's an in-memory database. So there's no persistent file. And when you're dealing with SQL injection, it's good to restart every single time. And so when the application, or when the connection is opened, it calls this DB reset, or clicks the DB reset button, and that just closes the main query and calls this DB reset command, which is this SQL here, which rebuilds our database. And it's reasonably large. So there we go. It's a bit over 1,000 lines of SQL. And so we can run this. And I can type ant into here and click search. And we see we get a bunch of things that contain ant. So it's Antonio and lots of restaurant. So things that contain ant in them. And the code for this is really basic. Select star from customers with customer name like, and then the edit text. Now, if you're familiar with how SQL injection works, you'll know that we can close our string, we can end the command, and then we can say drop table order details, and we could put a semicolon, dash, something like that after it, and then go search. And surprisingly, well, I was surprised when I initially did this. I thought this was going to work, but it looks like FireDAC is not running the second command. The first command is a select statement, and so I think it'll run a second select statement potentially, but it's not doing the drop table. So this instance of SQL injection does not work. So we can see that because we are closing the string, we are only getting things ending in ant. So restaurant. Now the other button, and this is the one that's a little bit more interesting. So update all customer names to test. So this is completely contrived. And we can say, see that it's basically the same, except it's an update statement rather than a select statement. And we're setting the customer name to test, where customer name like exactly as before. Let's pin that out of the way. Okay. All right. So if we go back to our application and call update, that looks like that's worked. But if I click it again, we'll see we get no such table order details because we've dropped it already. Now it's trying to drop it again. So our database is now broken. This customers, or is it customer? Okay, so we can't drop customers because there's a foreign key constraint. So having a database that has referential integrity is good in this respect. So that prevents customers from being deleted, but order details, that's just fine. So we've now got no more order details, and we could have said, where customer equals something or other if we knew our customer number, and clear our history. So to fix that, I'm going to change our layout to all code. There we go. So this should give us plenty of room to work with. So what we want to do, there are a number of ways we can fix this. The first is to quote our string. So I can do something like this. Oh, I do need a... So we should be able to do that. And now when we run, and I paste that into there, and we get update, it no longer works because we are quoting our string. But even better is to use a parameter. So like name, and in here I can say comma, and we want to put our parameter, so which should be this. And get rid of all of that. And now when we run, we'll effectively get the same. Except I want that one, update, and it's all good. And search, update, and we've got just those updated in that case. So that resolves that piece of SQL injection. We could reformat this. I think I could probably go % like that. Let's see if that's no, because it's a string. So okay, so that resolves that issue with SQL injection. I have one more example for you, and that's this login prompt. So we are creating an input query, we're grabbing a username and password, and then we are checking our database to make sure there is one user with that username and password, and if there is one user, we log in. And of course, we are not doing anything about escaping our strings or quoting them. And so when we run this, I'll use the universally default IoT password, and I have successfully logged in. But if I log in with admin and test, we failed. But if I go admin, end our string, and then make the rest of the SQL statement a comment, we have successfully logged in. And so, as you can see, we get to our username, and then our string is terminated, and then the rest of the SQL is a comment. So we end up with one user in the database being called admin, so we successfully log in. So that's just another example of SQL injection. And let's go back to our slides. And recommendations is use parameters on queries is probably the best thing you can do, but sometimes you have to build SQL through code, and so use quote_str or your string.quoted string to correctly escape your quotes, and that is a pretty good solution. But if you can, parameters are the best. So I've just got some random topics that we're going to go over next. We're going to look at second order SQL injection, so no more examples. So CSV injection, this is not really an issue anymore. So in your application, someone might enter in, so we've got a description of this equals import XML concat blah blah blah, and it's concatenating the contents of the spreadsheet and then sending it off to a website. So this doesn't work anymore unless you're running Excel 2002 or something like that. I've tried it with all sort of bunch of modern spreadsheets. So basically, if you're exporting CSV from your application, you need to make sure that it's not necessarily containing potential code and things like that. So anything that begins with an equals should be escaped. So as a general recommendations. So yeah, sanitize your inputs and outputs to avoid SQL injection. Escape any input strings. Use parameters. CSV injection. Worry about anything that begins with an equals. And yeah, I don't think this is an issue anymore, but it's an easy example to demonstrate. Slightly more difficult to demonstrate is PDF injection, where someone could enter in a surname or something like that that contains some PDF code, which might be to render a link which covers the entire page, and when someone clicks on that page, it then takes them to a website saying, please enter your credentials or whatever. And so, yeah, they could be harvesting usernames and passwords and that kind of thing. And HTML, XML, there is so many security problems associated with these that, yeah, that's just a huge topic. If you're outputting HTML in any form, good luck to you. So second order SQL injection. So let's say you had a category table and someone created a new category and typed in drop table customers. It's inserted correctly into the database because you've escaped it and the contents, the database has been updated rather than corrupted, but this is now sitting in your database. And if you then have some code that looks something like this, so select customers where the category equals and your category name, you are now restoring from backup because you've just dropped the customers table. So not only can't you trust data that's been entered by users directly, you can't trust data in your database either. So in every circumstance where you are getting a field, you need to make sure that it is properly escaped. And this can be true also if you are using numbers, because, for instance, if an edit box doesn't correctly restrict to numbers, or someone uses a Win32 application to make that text box now support strings, they could put in something else, and you've got problems again. So, yeah, next question: are you importing CSV or XML? And so, are you escaping that data correctly? And if you are escaping it correctly, are you then importing stuff that is potentially poisoning your database? So that's food for thought. And yeah, if you're using a database like SQL Server or something like that, and they support some sort of programmatic features, you need to make sure they're locked down as well, because that can cause all sorts of havoc, such as it might be enabled that you can run executables or something like that from SQL statements, which is a nightmare in itself. But anyway, other random topics. So DLL replacement. So if you have, say, using the OpenSSL DLLs, they could be replaced with ones that are effectively poisoned, and they could be forwarding off data to another website. Any data you think you're encrypting, you're actually sending off behind the scenes. SSL certificates, they're cheap these days, so you can make sure that your domain names are using HTTPS, like $10 a year or something like that will get you an SSL certificate these days. FTP, that's all plain text. So you need to be using FTPS or SFTP, and they're not very well supported directly in Delphi. You will need third-party libraries for that. Zip files, they support 64-bit now, which is nice, but they don't support encryption by default. You can add it manually. Excuse me, you can add it manually, but you could use Abbreviator or something like that. Passwords. You need to make sure your users choose appropriate passwords if you are allowing users to create them. So, a combination of uppercase, lowercase, digits, and symbols, but those in themselves are not enough. You also need to do a dictionary check, because password 1 exclamation mark conforms to this these four requirements. So you need to make sure that the word password is not in the password itself, or any other small number of words. Like, you make sure there's no 2-word combinations or something like that. So at least commonly used words. And last of all, make sure your exe is protected in some fashion, ideally with a certificate, so that's digitally signed, so that it can't be tampered with. And so people could potentially alter it's very easy to alter the resources in the DLL, so things related to the DFM file, so they could shift around events and all sorts of things like that. So that's potentially another source of concern. Learning more, I'd recommend the OWASP.org as just kind of a looking things up. They have just a huge number of exploits listed, and the basics of how to counter them. For a contract I have with a client, I have to complete a certain number of courses on securecodewarrior.com to continue my employment. So this is kind of more of a commercial thing. It's more geared towards large organizations, but it's a little bit gamified. And so they'll give you some code, and you've got to go through and find what the issue is with the code and how to fix it and that kind of thing. And of course, this is only really scratching the surface of application security. The topic is massive, and hopefully I've given you some ideas in this talk, and maybe there's more questions in the Q&A. So let's move on to that.